going to be looking at transformations of functions. Now, transformations themselves aren't too difficult if you can visualize them on a graph. However, when it comes to actually mapping out those transformations, that's where things can get a little confusing. Now, once we've gone through mapping transformations, it makes it a bit clearer as to why, for let's say positive translations of x, that it becomes x minus 3 in our function. But it does take a bit of time to sort of get used to that notation and working through mapping that way. Now, with transformations, there are three distinct types of transformations that we have that we can apply to functions. The first being your translation, so you're moving up, down, right and left. And then we've got our dilations, which are that sort of stretching away from the x or the y axis, or sometimes towards. And then we have reflections, so just that flipping of your function, whether that's in the x or the y axis. Now, when it comes to actually mapping transformations, we can kind of write out our original coordinates, right? And then we can take them into what we call our image coordinates, which we write down as x prime, y prime. Okay, so this is your original function here on the left. And then we have your image, which is your transformations that have been applied as they've been written down. Okay. Once we then have that mapping, we substitute that into the original function and then kind of solve for what we call the image function. And this is where your x's tend to be the opposite of what the transformation actually says, whereas your y's tend to do exactly what that transformation says. So we're going to start by looking at translations. Now, for translations, that's that movement of your graph, right? We're not changing the shape of the graph. We're not stretching it or reflecting it. We are quite literally just moving it left, right, up, or down on your axes. Now, if we were to map out that translation using that XY coordinate mapping I was showing you, you would have your XY being your original function. And then that would move to that x prime, so we call it x prime with that little apostrophe, plus your h, whatever that may be, so whether that's 5 or -7, and then your y prime plus k. But we're going to look into how that actually ends up becoming, let's say if we've got x moving 3 units in the positive direction, why that actually becomes x minus 3 on our function. So looking at this function here, we've got just a regular hyperbola. And what we're going to be doing with that hyperbola is we're going to move it 3 units in the positive direction of the x-axis. So we're going to move that 3 units to the right. And then we're going to do 2 units in the negative direction of the y-axis. Now, some of you might already be able to tell me that this will end up being y is equal to 1 on x minus 3 minus 2. But I'd like to kind of go through how we actually get there. Now, when we write out our mapping, we're going to start with our x, y, and then we're going to apply our transformations exactly like how they are written, okay? So we're saying 3 units in the positive direction of the x-axis. Well, that's going to be x plus 3, right? And then we've got 2 units in the negative direction of the y-axis, becomes y prime minus 2, okay? Now what we're going to do is solve these for x prime and y prime. Right, so I've got x is equal to x prime plus 3, and that means x prime is equal to x minus 3. We're going to do the same for our y. We've got y is equal to y prime minus 2, which means that y prime is equal to y plus 2. Okay. Now what we're going to do is sub this back into our original function. So we originally had y is equal to x. Well, now what we've got is y prime is equal to x prime, because this is our image function, okay? Now that we've kind of established that, well, we can sub in the y prime and the x prime that we found. So now we've got y prime plus 2 is equal to 1 on, I'm sorry, that should be f of x prime, but 1 on x minus 3, and then we would solve, pardon me, for y, okay? So in doing that, we would have 2 subtracted from both sides, giving me 1 on x minus 3 minus 2, which we can see is what we had written up there originally. So because of that subbing in, as you can see, x doesn't get altered any further once it's subbed in. It's that y that kind of gets flipped again. And so x is the opposite because that's what we had to begin with, and then y, because we subtract and then re-add, that's why all our y transformations do exactly what they say. Now with dilations, this is one where you have to remember to work with the opposite coordinate on the axis, right? So if we have a dilation from the x-axis, so in that vertical direction, then we're going to be affecting our y-coordinates. Whereas if we have that horizontal direction from the y-axis, we're going to affect our x-coordinates. So vertical dilations, if I'm working with xy going into something x prime, y prime, well, vertical dilations have an effect on the y-axis. And so it's going to become, with a dilation factor of a y prime, okay? Horizontal dilation, same sort of idea, except our xy is going to go into ax prime, y prime, okay? If we had a reflection, that would just mean we had a negative dilation factor, right? So that means that instead of ax, it would be negative ax prime or negative ay prime. Okay, so reflections are quite literally having just a negative dilation factor as opposed to a positive one. Now, in terms of applying these dilation factors, we're going to follow those same steps we did before. Okay, so I've got my original xy coordinates, and they're being mapped. Because we're dilating from the y-axis, we're going to map them to our x prime. So that's going to be half x prime y prime, because the y is untouched in this case. That means y is equal to y prime, that stays untouched, and then x is equal to half x prime, which means x prime is equal to 2x. We're now going to sub this in to our original function. So we know y prime is equal to x prime, f of x prime, and through subbing that in, I'm going to end up with y is equal to 3 on 2, and then our x prime is 2x. So this becomes 3 on 4x, being our transformed function. Now, if you were to graph this, what you would find is your 3 on 2x is a bit further away from the y-axis than your 3 on 4x because of that dilation factor of a half. Now, with transformations, we can also combine them, right? We're not just stuck to doing only dilations, only reflections, and so on. Now, the order that we have to follow for the transformations is D for dilations, R for reflections, and then T for translations, unless it's otherwise specified, okay? Now, if we wanted to map a combination of transformations in this order, that means if, let's say, we had a negative dilation factor, it would be negative ax prime plus h, negative y prime, plus k. Okay, so that's if we were to do it in the correct order. Obviously, if it's otherwise specified, you do have to work with what you've been given. So when working with a combination of transformations, I like to figure out, well, what am I doing to my x and what am I doing to my y? So reading through this, we've got a hyperbola once again. We have a dilation of factor 2 from the y-axis, so that is an x-coordinate effect. A reflection in the y-axis once again affects the x-coordinate, and then a translation of 1 unit parallel to the x-axis, so that they all affect the x-axis, and then a translation of negative 2 units parallel to the y-axis, that's going to affect my y-coordinates. Now, something to watch out with this question as well is they've given you what should be your final notation for this question. So using our mapping, I'm going to start with just our usual x, y, and then we're going to apply those transformations in the order we were given. So we have a dilation of factor 2, and then we've got a reflection, so negative 2, x prime, and then we've got plus 1 in the x-axis. And then for our y-coordinates, well, we don't have a dilation or a reflection, we've just got that translation. So we have y prime minus 2. Now solving this, once again, we've got x is equal to negative 2 x prime plus 1, and that means x prime is equal to x minus 1 over negative 2. Okay, same thing for your y's. We've got y is equal to y prime minus 2. So y prime is equal to y plus 2. Okay, now we're going to sub this in. We know that our y prime is equal to f of x prime. And so now I've got y plus 2 is equal to 1 over, and then we've got that whole x minus 1 over negative 2. Now what that means, if you were to do your keep flip change, our negative can stay out the front in this case, but we'd have negative 2 over x minus 1 is equal to y plus 2. So y is equal to negative 2 over x minus 1 minus 2. Okay, so our final transformed function is negative 2 over x minus 1 minus 2. Now the last thing you need to be able to do is to determine the transformations that have changed one graph into another. So the best way to go about this is to look at your original function and then try and pull out any transformations that you see. Now it is a bit hard to do this, but what we've got is y prime, oh my goodness, y prime being equal to 2 over x prime minus 3 plus 5, okay? Pulling things out from here, I've got y prime, and I'm going to pull that 2 out from there, and that becomes 1 on x prime minus 3 plus 5. Then we can kind of rearrange from here. I've got, sorry, not rearrange necessarily, but I can write this out as y prime is equal to 2 of f of x prime plus 5. And so what I can see here is that y prime has gone through 2y plus 5. And then I've got x prime is equal to x minus 3. Okay. Sorry, x is equal to x prime minus 3. So even I'm getting a bit confused sometimes when it comes to transformations. If I rearrange this one for x prime, I get x plus 3, right? So this bit here should actually be x minus 3, as that bit doesn't change originally. Now, from here, what you can see is that we've got that transformation here of a dilation of 2, if we're looking at our y prime. So a dilation of 2 from the x-axis, followed by our translation, okay? So we've got our translations of 5 units in the positive y direction, and then 3 units in the positive x direction, okay? So when you are trying to determine the transformations, you want to pull out the original function and work from there, okay? Because it's a lot easier to see, especially what's happened to your y when you pull it out and leave it as f of x, right? So 3 units in the positive x direction.